Namaskaram. Hello everyone. In this class, we are going to discuss about some of the numerical examples on Centroid. Before watching this, if you have not seen the video which explains the centroid and center of gravity, the difference between centroid and center of gravity, the difference between these two, and some of the formulae which gives centroid for some of the standard figures like triangle, rectangle, circle, semicircle in different direction, and quarter of a circle. So please go to the channel and watch the last video so that you can clearly understand the numerical examples here. Let's go to the first example. In these examples, as you can see in this figure, we have the T section which has the flange of dimension 600 mm by 100 mm. Say 600, and this dimension is 100 mm, and web of depth 800 mm and width 200 mm. So if you want to write this as a plane figure, we have the flange, we have the web. Those who don't know, this is the flange, and this we can call it as web. So in the T section, we will be having one web and one flange, and in the I section, we have two flanges and one web. So now the dimension has been given. The web depth is 200 mm. The flange depth is 100 mm. So width of the flange is 600 mm. The total height of the web is 800 mm. So what we need to do? We need to calculate the centroid for this. First step is write the reference axis. For your reference, you take like this. In future, we can change also. So take leftmost line for the plane figure as y-axis, and bottommost line which is attached to the plane figure as x-axis. So we have x-axis, y-axis as the reference axes from which we need to calculate the centroid. We have 200 mm by 800 mm as the web, 600 mm by 100 mm as the flange. Now we need to calculate x bar and y bar. So we have the formula for any plane figure. X bar is equal to a1x1 plus a2x2 divided by a1 plus a2, etc. So what we need to do, just look at the figure. If I take this, the center of this must be our centroid. So x bar is the distance from y-axis to the center of this. So when I have this at the center axis, just look at this. From y bar, the distance is 600 by 2. Why? About the centroidal vertical axis, this plane figure is symmetrical. Just looking at this, you can find out this is symmetrical. This section and this section is same. So by looking at this center of this, you can find out easily. No need to apply any formula here. Simply I can write 600 by 2, that is equal to 300 mm. The unit given is millimeter. Now we'll go to y bar. Formula for y bar is a1 y1 plus a2 y2 plus, if you are having any plane figures, you need to add that. Here I have only two plane figures, so a1 plus a2. Now if you take y bar, first look at this. I am taking this top plane figure as 1, the second plane figure as 2. Here in this case both are rectangles, so I need to use the formula only for the rectangle. Now a1, 600 into 100 into, this is the a1, and y1 is a distance from the x-axis to the center of this. So this is the distance. So now if I want to calculate this distance, this 800 plus half of this. The centroidal distance from x-axis to the first plane figure is 800 plus 100 by 2 plus a2 y2. a2 second plane figure is 800 into 200 into y2 from x-axis to the centroid of the second plane figure, 800 by 2. This is the rectangle, just I am writing as it is. Now 600 into 100 is the a1 plus 800 into 200 is the a2, area of second plane figure. If I solve this, I will be getting y bar is equal to 522.73. So from where I am getting? From the bottommost layer. So x-axis and y-axis, whatever we have taken, is only for the reference. So from bottommost axis, the distance for the centroid of this plane figure is 522.73. So I can write that as y bottom, that is 522.73 millimeter. Next, y top is the total depth, 800 plus 100, 900 minus 522.73. So y top is equal to 377.27 millimeter. So these are the distances from the centroid. So this is the centroid at a distance of 522.73 for this plane figure. Do this example. Here we have combination of T and L beams. By looking at any structure, you can find out these type of structural plane figures or the structural elements. So this is the L beam we have. Here we have one flange and one web. And if you take the T section, this is what the dimension of that T section has been given. Width of the web they have given 150 mm. Depth of the flange for both is 75 mm. Then total height, if they have given, you can find out what is the depth of the web. The total height they have given, it is 300 mm. So width of the L beam is 300 mm. This is 300 and this is 400. So take two examples which have the L section. So L section 300 mm. This depth 75 mm. The total height is 300. So this will be 225 millimeter. And width of the web of the L beam and T and L beam is 150 mm. So take this as 1 and second is T section they have given here. It is a combination of beam and slab in the structure. 400 mm, 75 mm, again it is 225. Width of the web is 150 mm. Take the structures, do this as homework problem. Next, you might have seen the machineries like this. In this we'll be having various structural elements or the plates, bolts, machine parts will be there. That machine parts will be there in various forms like rectangle, semicircle, and sometimes you'll be having the holes inside, and you'll be having the rectangle, square, and sometimes you'll be having the triangular plate. So all these things will be there that you need to calculate. If you need to calculate triangle, the centroid for that, just look at this. So if I take this plane figure, I have this rectangle, then semicircle here. If I go to this, I have a plane figure. Determine the centroid of a compound section of size as below. The rectangle size is 100 mm by 60 mm. In fact, in this plane figure, this dimension is enough. So diameter of the semicircle you can find out from this only. 60 mm is the diameter. As I told you, take bottommost as x-axis and leftmost line as y-axis. Take this as first plane figure and this as second plane figure. So as I told you, we need x1, y1. We can write now itself. This is your x1. From the y-axis to the centroid of second plane figure is your x2. Similarly, this is your y1 for the first plane figure. For the second plane figure, y1. y1 is common because if I draw a centroidal x-axis, the area about x-axis is symmetrical. So I can write simply y1 is equal to 60 by 2. That is 30 mm. Just look at this. What you have, the centroidal axis is this. So if I take the center of this, above this and below this is symmetrical. So when I am having symmetrical section, simply by looking at the plane figure itself, I can write what is the centroid. So now we need to calculate. It is y bar. X bar, we have the formula a1x1 plus a2x2. Only two plane figures. I am writing a1x1 plus a2x2 divided by a1 plus a2. Now if I go for that, x bar is equal to a1, area of first plane figure is 100 into 60. x1 is from here to centroid of the first plane figure, that is 100 by 2, it is equal to 50, plus pi into 60 square by 4 whole divided by 2. Pi d square by 4 is the formula for the circle. Pi d square by 4 divided by 2, half of that is the semicircle, into, so I can write 100 plus 4 into 30 divided by 3 pi. See, this is the formula. This I have. For this I need to write the formula 4r by 3 pi. Total diameter is 60 mm. The radius is 30 mm. Divided by 100 into 60 plus again pi by 4 into 60 square whole divided by 2. So x bar is equal to, if I calculate this, I will be getting 61.96 millimeter. So x bar is 61.96 and y bar is 30 mm for this plane figure. Then look at this machine. In this, as I told you, you have various sections like circular section, rectangular section, and look at this, we have triangular section. If I take this, then I have this semicircle, In that I have the hole. So that hole has to be removed. So that is not coming to our plane figure whatever we have here, but that needs to be removed in a proper manner. How we are doing that? Just look at this. See, I have rectangle, triangle and a hole inside the machinery part. Now, as I told you, I need to take the bottommost as x-axis and leftmost line as y-axis. If I take x-axis and y-axis, and next we need to divide the compound plane figure into number of plane figures for which we have the centroidal formula. See, triangle we have, this is the triangle. I am notifying that as first plane figure. Next, second plane figure, the rectangle. And in that, the one portion, that is the circular hole, has been removed. So just that has to be removed from this. Okay, but anyway we are removing, but that is the plane figure which is there in this compound plane figure. So I need to denote that as 3. So we have 3 plane figures. So the formula will be y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. But here the third plane figure has to be removed. So that you need to write that as minus. Here also this as minus. So now if I take y bar, the formula as it is a1 y1 area of into 60 into 30. So total they have given 60. This has 30 mm and this 60 mm. Then we have depth of this as 40 mm and from here to this is 20 mm and from here to here the distance is 5 mm. So from the right edge of the rectangle we have 5 millimeter and from the bottommost edge of the rectangle we have the distance of 20 millimeter for the circle, the circular hole. So now I am writing this y bar is equal to half into 60 into 30 and centroidal distance from x-axis to the center of the right angle triangle. So right angle triangle from the base, what is the height? This will be the total height divided by 3. So this will be 30 by 3. Then half into 60 into 30, 40 plus 30 by 3 is the distance. Then 40 into 60 into 40 by 2 for this, for the rectangle. 40 into 60 is the area, 40 by 2 total height. So of the depth, this total depth is 40. From this distance is 40 by 2, so that is 20 mm. Next, minus. So pi by 4 into 10 square. See, circle, I am writing the area of the circle into the distance is from the y-axis to the center of this. So this distance they have given, it is 20 mm. From here to here, the total diameter of this circular hole is 10 millimeter. So from here to here it is 25 millimeter. So I am writing as it is, divided by total divided by, so half into 60 into 30 is the A1 plus 40 into 60 is the A2 minus pi by 4 into 10 square is A3. So what we need to remove? Just I need to remove the circular hole portion, so that has to be provided with the negative sign. So if I do that, I will be getting y bar is equal to 28.26 millimeter for this problem. So y bar is equal to 28.26 millimeter. Now I need to calculate x bar also. Similarly, I have the formula a1 x1, a2 x2. Now I need to write minus a3 x3 divided by A1 plus A2 minus A3. If I substitute all those things, I will be getting x bar is equal to 26.72 millimeter. So we'll see how to calculate x bar here. X bar, as per the formula, A1 is area of the triangle, half into 60 into 30, into the distance we have here is, for that, from, this is y-axis, this is x-axis, from y-axis to the center of this. So that will be, the total is 60, the 60 divided by 3, 60 by 3, plus 60 into 40 is the area of the rectangle, 60 by 2 is the distance. Minus pi by 4 into 10 square into 50 divided by half into 60 into 30 plus 60 into 40 minus pi by 4 into 10 square. So if I calculate this, I will be getting x bar is equal to 18,000 plus 72,000 minus 3927 divided by 3221.46. X bar is 26.72 millimeter. So for this plane figure, I am getting x bar as 26.72 and y bar as 28.26 millimeter. This is y bar and this will be x bar. So that is the centroidal distance. So with this, we are solving some of the problems like this. If you want to solve some more problems, please subscribe and comment on the box.